everyone, we're headed towards working with radicals exclusively for a little bit here, but to get us going, we're going to continue with this back and forth between radical form and exponent form, because a lot of times the thinking going on in the background with radicals does involve exponent rules. So that's what this problem is really about. They can look really messy, but if we have radicals, one option we always have is to rewrite with exponents and use exponent rules to simplify. So for this first one, we have a fourth root of x cubed, which can be rewritten as x to the 3/4. Remember that the root is always going to go in the bottom of the fraction. We're multiplying that by the cube root of x to the 5th, which can be rewritten as x to the 5/3. Exponent rules say that you can combine those two by adding exponents, 3/4 plus 5/3. And some of these are kind of annoying fraction-wise, but you don't have a ton of them to do, so we'll just have to do a little fraction arithmetic. Again, great thing to be practicing by hand. Don't get relying on calculators. We want to get really good at this arithmetic if we're not already. Within reason, sometimes they're terrible, and I'll forgive you, but mostly try and do a lot of this work by hand. 3/4 and 5/3, the common denominator is going to be 12, so we'll do 3/3 and 4/4. Which means we have 9/12 and 20/12, which is going to give us 29/12. X to the 29/12. And that's a great answer in exponent form. This did ask us for radical form. So this is the 12th root, remember roots are always in the bottom, of x to the 29. Very messy, but just to see that we can play around with these rules no matter how messy things get. We will see a lot as we move forward of the roots matching, so both square roots or both cube roots, and that will make this a little cleaner, but we can tackle even something this messy just by using our exponent rules. The next one is similar, but it's a division, and remember that for division we'll subtract exponents. So the fourth root of x cubed, again, was x to the 3/4. Put the root index in the denominator, and x to the 5/3 for the bottom. So now we're trying to do 3/4 minus 5/3. So back here, we can look at these. This just becomes a minus. So we've got 9/12 minus 20/12, which will give us negative 11/12. X to the negative 11/12. And if we're going to write that in radical form, I think we want to deal with that negative exponent first. So that's going to be 1/x to the 11/12. And x to the 11/12 is the 12th root of x to the 11. And again, you can put that 11 under the root or outside the root. I was encouraging you to put it outside. Here where I'm not trying to actually evaluate, I don't have a number as the base that I'm actually trying to raise to an 11th power. It doesn't matter, so I've kind of flip-flopped, but either should be fine. Last one, and I think this one is actually a really nice use of this. How do you take the cube root of the 5th root of x squared? And the answer is that exponents will tell you how to do that. So remember, a cube root is a 1/3 power, and a 5th root is a 1/5 power, but we're squaring, so that'll make it 2/5 power. And the exponent rules say you should multiply those powers together. So we get 2/15, which is the same as the 15th root of x squared. So the answer is that the cube root of a 5th root is the same as a 15th root. You actually multiply those, which I don't think is obvious at all until you use those exponent properties. All right, thanks for watching.